Alright, just like we finished in the last video, we were showing how to distribute a monomial times a binomial. Now in this problem that we have here, we have a monomial times a trinomial. So this is just an extension of what we did last time. Instead of just multiplying it to two terms, here we have to multiply this monomial to these three terms. So we're going to start one at a time. 4xy squared times 7x cubed would be 28. For the x's, since we're multiplying like bases, we have to add the exponents, so that would be x to the fourth, and then our y squared. Now, we're going to distribute it to the 3x squared y squared. I'm going to do this in a different color so you can make sure and see these happening. So 4xy squared times 3x squared y squared is going to be a positive 12. For our x's, again, we need to add the exponents, so that would be x cubed. And for our y's, we need to add the exponents also, so that would be y to the fourth. Now we need to distribute to the last term. So 4xy squared times negative 9y cubed would be negative 36x. And for the y's, we have to add the exponents again, so that would be y to the fifth power. So our final answer looks like this. Now let's look at a different type here. In this problem, let me back up just a hair there so you can, we can see some arrows here. Okay, now in this problem, we're not multiplying a monomial times something. We're multiplying a binomial times a binomial. Now, if you've gotten down pat the idea of distribution and just distributing that multiplication throughout the parentheses, then this will just be an extension of that. We're going to start off by distributing this a throughout the parentheses to the next binomial. So a times a would be a squared, because remember, multiplying like bases, we have to add the exponents. And a times negative 2 would be negative 2a. Now, we have distributed this a completely to that second binomial, so we're done with it. Now we have to distribute or multiply that positive 7 to everything behind it in the parentheses. So positive 7 times a would be a positive 7a. And a positive 7 times a negative 2 would be a negative 14. Now we have completely distributed this problem. Now it's a matter of, can we combine anything? Can we make it a little bit simpler? And we see that we absolutely can, because we have some common terms there. So let's see, we'll have a squared. Now we can combine the minus 2a and the plus 7a. When we combine those together, we get a positive 5a and then our minus 14. And we can't combine any other terms. None of these are like terms. So we're done at this point. Alright, let's try to do the next one also before we run out of time here, because this is the same exact concept, a binomial times a binomial. So I'm going to start out by distributing the x. So we'll have x times x is x squared, and x times negative 2/5 would be negative 2/5 x. See, those fractions weren't bad in that problem. Now we're going to multiply the 3/5 to everything behind it in the parentheses. So 3/5 times x would be plus 3/5 x, and 3/5 times negative 2/5 would be negative 6 over 25. Remember, just multiplying numerators and denominators. Now we have some like terms that we can combine. So we have x squared. Since these have the same denominator, it's not bad. We just take the minus 2 and the plus 3 would be a positive 1 over 5x, and then minus 6 over 25. So this is the multiplication of those binomials.